8-2, Sequences and Equations. In this lesson, we'll describe how sequences using words and symbols, and we'll also find terms of arithmetic sequences. We have new vocabulary, sequence, term, arithmetic sequence, and common difference. A sequence is an ordered list of numbers. Each number is called a term of the sequence. When the difference between any two consecutive terms is the same, the sequence is called an arithmetic sequence. The difference is called the common difference. So let's look at the why question. It says giant pandas spend more than 10 hours a day searching for food and eating. The table shows the average amount of bamboo a giant panda eats. Focus on why. Let's look at A. As the number of days increase by 1, how much does the amount of bamboo increase? And to answer this question, we must rely on the table here to our right. The table gives us the number of days, which is going to be represented normally by the letter N. So I'm going to write N here. Then it says the total amount of bamboo, and that's normally our term number represented by the letter T. So the question asks, as the number of days increase by 1, how much does the amount of bamboo increase? And looking at the table, on day 1, a panda would consume 30 pounds of bamboo. Day 2, 60 pounds. Day 3, 90 pounds. Day 4, 120 pounds. So for each day that goes by, what's happening? It's increasing by 30. So we're adding 30 each day. So the answer to this question, how much does the amount of bamboo increase by? The answer is 30 pounds. Now let's look at question B. How much bamboo would a giant panda eat in 5 days? Notice that the table only extends out to 4 days, so we can extend our table and add another day, which would be our 5th day, to calculate the total amount of bamboo. So we know if it's increasing by 30 each day, we can write an equation. The equation would be 30, the amount that we know is increasing by each day, times N, the number of days. And it's asking us for 5 days, so we say 30, and we'll replace N with the number 5, and we'll do the order of operation. So 30 times 5 is 150 pounds. So in 5 days, the panda will consume 150 pounds of bamboo. So these are the type questions we're going to have to deal with in this section. So let's move to example 1. Example 1 deals with describing an arithmetic sequence. It says describe each sequence using words and symbols. 6, 7, 8, 9. Notice that this information has been transferred to the terms part of the table. For any time you see a question like this, you're going to set your table up having your term number. Remember I showed you it's going to be represented by N. And it's normally going to increase by 1, 2, 3, 4. And that's the difference of the term number. That's the number across the top. Then your term is represented by whatever the question is asking you. 6, 7, 8, 9, the arithmetic sequence. So you will plug in 6, 7, 8, 9 in your table. Then you ask yourself, what's happening from each term number? What's happening from each term number? So from 6 to 7 is increasing by 1. 7 to 8, increasing by 1. 8 to 9, increasing by 1. Therefore, the terms have a common difference of 1. A term is 5 more than the term number. So the equation that's described in the sequence is T equals N plus 5. And we can look right here. So my term is 1, which is N. If I substitute 1 for N, I should get 6. But I don't. I only get 1. So how many more do I need to get 6 plus 5? So my equation would be N plus 5 to get my term each time. So this would work for any number that I plug into this table. Okay? Let's look at example 1B. It's asking for 4, 8, 12, and 16. Again, they've taken the information and plugged it in the table for the term. From 8 to 4, it's increasing by 4. From 8 to 12, plus 4. 12 to 16, plus 4. The term has a common difference of 4. A term is 4 times the term number. So the equation that describes this sequence is the term equals 4 times the term number n. So we plug in 4 n. Let's say we wanted to know what the 5th term was. If I substitute 5 for this n, I can find the 5th term is going to be 20. And as you can see, it works, because from 16 to 20, that is plus 4. Okay, let's work a few. I've already set up the guided practice problems here, and on your own, I want you to fill in the table with 10, 11, 12, and 13. Now, the common difference is what? That's right, it's 1. So we're increasing by 1 for each term. So the term is n plus what? And that's the challenge that you're going to be faced with, finding what has to be added or multiplied to our term number to get our term. If we have our term number is 1, if I replace n with 1, what should I get? The table shows that I should get 10. But if I only have 1, how many more do I need? 9. So my equation will be term equals n plus 9. N plus 9. Let's test our equation. Let's test it for the 5th term. So I plug in 5 for n plus 9, we should get 14. And it works because our table is still increasing by 1. Okay, let's look at example 1B. We will plug in our terms, 10, 15, 20. Find our common difference from each term to the next. What's happening? It's increasing by 5. So our term is going to be 5n, because we're increasing by 5. So we're going to multiply 5 times whatever our term number is. So what would be our 5th term number? So if t equals 5 times n, what's t? 25. And as you see, it works because we're increasing by 5. It's still increasing by 5. And those are examples of how to do problems with the arithmetic sequence. Let's move to example 2. Example 2 deals with finding terms. You can use rules to extend patterns and find other terms. And I like your text. It gives you a study tip. It says arithmetic sequence is a function. The equation describes the sequence in the function rule, and the term numbers are the inputs. Remember we talked about input, output, independent, dependent, domain, and range. Now we have another word we can add to that list. Term number is our input. That's our quote-unquote X. and our term would be our quote-unquote y. Okay? For example 2, it says, write an equation that describes the sequence 7, 10, 13, 16. Then find the 15th term. Okay? They set up our table. The difference of the term numbers is 1. That's normal. Then the common difference of the terms is 3. So from 7 to 10 is 3. 10 to 13 plus 3. 13 to 16 plus 3. It says the terms have a common difference of 3. The difference is 3 times the difference of the term number. This suggests that t equals 3n. However, you need to add 4 to get the value of t. Okay? This simply means that if we just stopped with this and said that this was our equation, would we get 7? Would we get this 7? And we can test it. So what's 3 times 1? That's only 3. But my table says that my term number should be 7. So how much more do I need to add? I need to add 4 to my equation to get the correct term number. However, you need to add 4 to the value of t. So t equals 3n plus 4 describes this sequence. Again, that's going to be your challenge, knowing what to add or what to subtract to have the right equation. It says check. If n equals 2, then t equals 3 times 2 plus 4, or 10. Use the equation to find the 15th term. Let n equal 15. So we replace n with 15. That's 3 times 15, which is 45, plus 4 is 49. So in our table, if we had to extend this all the way out to 15, the 15th term would be 49. These are the type of problems that we're going to deal with in class tomorrow. So if you want to get more practice, you can do the guided practice problems on the bottom of page 406 under guided practice example 2. Guided practice example 2. Now the real life problems that we're going to encounter in the classroom setting are the ones that require you to think more and to manipulate things with your hands, and we're going to have a couple of labs that we deal with this lesson. Real world example 3. Find the term in the arithmetic sequence. Here they have, I don't want to call them Martians, but they're like supposed to be people sitting at a table. It says the diagram shows the number of square tables needed to seat 4, 6, or 8 people at a restaurant. How many tables are needed to seat 16 people? So it's like they're giving you a lot of information. They're giving you the mock tables, then they give you the generic table that we've been using for the other 2 examples. It says make a table to organize your sequence and find a rule. Okay? So to match our table, if this is the first table, how many people are there? 1, 2, 3, 4. So that matches here. If this is our second number of people, how many are there? 1, 2, 3, 4, 5, 6. And this is our third setting. So we have 1, 2, 3, 4, 5, 6, 7, 8. And they want to know the pattern for 16 people. And then we would do the same thing we've done in the other examples. We'll set up our table. Now we have a specific name. Notice we don't have our N and our T anymore. We're talking about something very specific. Number of tables, number of people. So when you deal with real life problems, make sure your table reflects what you're talking about. So we have number of tables. For this table, we have 1 table. How many people are sitting at the table? 4. We have 2 tables. How many people are seated? 6. We have 3 tables. How many people are seated? 8. So that's the thought process when you're working with real life problems. think about what they're asking you. It says the pattern in the table shows the equation to be people equals 2 tables plus 2. 2 tables plus 2. Okay? So let's see if this works. Write the equation. Let me show you how they got this equation. What's the common difference at the bottom? Plus 2 every time, right? So we know we're going to have 2t. But if we stop here, would we get the number of people? So let's say 1 table times 2, what is that? That's just 2. But we need how many people at the table? 4. So I need to add 2 to this equation to get the 4 people that my table shows already. Okay? So we need to have an equation that will work for all, which we do. P equals 2t plus 2. And we're trying to see how many tables are needed to seat 16 people. So now we're working in the reverse. We know we need a table for 16 people. Right? So now we need to solve for t. T represents the table. So the first thing I need to do is subtract 2 from both sides, remembering how to solve an equation. So 16 minus 2 is 14 equals 2t. Now I need to divide by my coefficient, which is 2. 14 divided by 2 is 7. 2 divided by 2 leaves t. So I will need 7 tables to seat 16 people. To seat 16 people. Now on your own, I want you to do the guided practice problem example 3. For this problem asks you how many tables shaped like hexagons are needed for 22 people. If you model the example that I just did for example 3, you should be able to answer this question. When you come to class tomorrow, have your answer for this guided practice problem. And we will have a question and answer session related to any questions that you may have about anything that I just discussed, and then we'll go into working our problems. If you have any questions on the lesson, please post them on my blog, and I'll respond as soon as possible. Have a great day.